Hello.
Hello.
Hi Diksha Didi.
Hi.
So this is our first class of our advanced course. So this is going to be very interesting and um, we are gonna learn a lot. We are gonna go a lot deeper in C++ in this course.
Okay.
All right. So just I just wanted to ask, do you remember um, the previous things in the basic course that we learned, or should we just go over them once?
No, I remember them.
All right. So over here in the advanced course, we have first we have this theory that we'll read so that we get deeper insights into C++. Like we know what C++ is, like exactly how it works and how it's better than other languages. And we're gonna see advantages and disadvantages in details, so that we know that why we are using C++, what is the cause of using C++. So we are just gonna read these two introduction to C++ programming language chapter. It's named like that, but it's actually going pretty deep. And we are also gonna see the programming basics, where we are gonna see more features that C++ has. We have already learned basic like struct, classes, functions, loops, etc. But we are gonna see a lot more today, so let's just get started with it. All right. So C++ we know is a general purpose programming language that was developed as an enhancement of the C language to include object oriented paradigm. So C was a functional language, which is also a type of language where everything is based on functions, whereas C++ is an object oriented language where everything is an object that we already know. So it is an imperative and a compiled language. So it's a compiled language, meaning a compiler converts it into binary code and then the computer is able to understand what the code is. All right. So we are gonna see some pointers over here on C++, that will tell us about C++. So that it is a high level general purpose programming language designed for system and application programming. So it was designed for application programming and system programming. Right, so it was developed by Bijan Strausstrup. I still can't pronounce his name, at at Bell Labs in 1983 as an extension of the C programming language. So it's an extension of a C programming language. So it's object-oriented a multi-paradigm language that supports procedural, functional, and generic programming styles. So it's just telling us that it's a object oriented language where you can create functions. It's you can also do functional programming. You like everything can be based on functions also. So it is as it is when you're learning C++, you're kind of automatically learning C. How? Because it is an extension. C++ is an extension of C++. Sorry, C++ is an extension of C. So when learning C++, you will get a basic idea of C also, right? Because C and C++ are very similar. Just C++ is object oriented and C is a functional programming language. All right.
Okay.
So one of the key features of C++ is its ability to support low level system level programming, meaning you can work with the memory. It's not C++ is exactly not a high level language. It's a level language, you can say, as you can work with the memory of your system. Like you can we learned about pointers and references, where we can store the value of the memory location, and we can also change directly the value in the memory location, right? So using pointers we could directly change the values that were there in memory location, and using references we were able to create multiple variables pointing to the same memory location, right? So
Okay.
the C++, how it's unique from other high level language, it lets you work with the memory. It lets you go on the low level and work with the memory of your device, right? So it's closer to the system hardware, or you can say it's closer to the system, right? So at the same time, C++ also provides a rich set of libraries. So there are many libraries. Like in Python, you have many libraries. In C++ also, you have many libraries which will help you while coding, and it will make your tasks easier, right? And features for high level programming, high level application programming. So there are many features through which you can do high level application programming, making it a popular choice for developing desktop applications, video games, and other complex applications. So it has a large active community. So one of the advantages is that there's a large active community of developers and users for C++. So whenever you have a problem, doubt, or something, you there's such a large community, you can post your question and you will get support from other people who already know C++. So one advantage is that it's so popular, and it's so widely used that there are a lot of sources also online regarding C++. So there's no problem in the learning part of C++. Like this website Geeks for Geeks, here they have taught C++ in detail, right? So this is a part of the advanced course, everything on Geeks for Geeks, and we are gonna see a lot of new things. So
Okay.
templates. So C++ templates allow developers to write generic code that can work with any data type, meaning it is easier to write reusable and flexible code. So you can take other people's code, right? And it's easy to reuse code, right? And basically the advantage of object oriented programming languages is that you are able to reuse code, right? And then you have standard template library. In this HTL provides a wide range of containers and algorithms for working with data, making it easier to write efficient and effective code. So you have a standard template library that provides a wide range of containers and algorithms that we can use when working with data, and making that makes it easier to write efficient and effective code. And we have exception handling next. So C++ provides robust exception handling capabilities. So any exception or error is there in your program, you can handle it properly, right? So it won't just crash your application. Exception handling is it has C++ has many exception handling capabilities. So if you want, you can handle your exceptions very effectively using C++. So overall, C++ is a powerful and versatile programming language that is widely used for a range of applications and is well suited for both low-level system programming and high-level application development. So you can do low-level system programming, or you can create high-level applications. You can do both of these with C++. So here's our basic program, and where we are just using the cout method to print hello world, and then we are returning 0. So over here, just a small question. If we don't want std, what we will we give over here? A division question.
The name stream actually.
The using namespace, right? So the using namespace standard, yeah. So we just gave it using namespace standard. So this tells C++ which namespace to use from IOStream. So cout is a part of namespace standard, so that's why we are able to get a cout.
Could you send me that link again that you sent me in probably first or second class of that Geeks for Geeks site? I actually changed my phone, so my chats got deleted.
All right. So the link of the practice questions, or for the basic course one?
The basic site that was
All
that
right. All
you were
right.
teaching from.
All right. I'll just send you after this class.
Yeah, sure. Thank you.
Yeah. So when we run this, we are gonna get hello world on our screen, and you may notice that we have given standard and endl over here, though we did using namespace standard. That is one thing in C++. If you are using namespace standard but you still give standard, that's not a problem. right? But if you don't give using namespace standard and don't give standard, then it will search in the iostream library, and it won't find your cout and endl as they are part of your namespace standard. So if you are saying using namespace standard and you still give standard, that will not raise an error. So as you can see, we were using standard endl over here, though we were doing using namespace standard. So when giving a standard over here or removing it, that won't make a difference, as we are already doing using namespace standard. So this will bring the same result.
Okay.
All right. So endl was bringing a new line. So over here, as you can see, this is showing how C++ code gets executed. So we have the C++ source code that is compiled and it is turned into machine code, right? So it's turned into machine code like this. And over here, they are mentioning over here that C++ is a middle level language, right? As you are able to work with the memory and you are able to directly change your value of the memory that is there in C++. Like you remember where we had the memory location of some value and we were just directly changing that value in the memory location using references and pointers.
Yeah.
Yeah, so
Yes.
that's why C++ is called a middle level language, as you're directly able to work with the memory. So
Okay.
so C++ is a middle level language, rendering it the advantage of programming low level like drivers and kernels, and even higher level applications like games, GUI, desktop apps, etc. So the basic syntax and code structure of both C and C++ are the same. So basic, as I told you, the basic syntax and the code structure of both C and C++ are the same, as C++ is just an extension of the C language. So, some of the features and key points to note about the programming language are as follows. So, it's simple, right? So, it's very simple. It is a simple language in the sense that programs can be broken down into logical units and parts, and you whatever you write, you are able to understand by looking at the code, as the syntax is very close to our normal english language. So whenever we write some c++ code, we are able to understand. When we refer that c++ code later on, we will know what we are writing. So if we are what we have written, for example, we write a program and we refer to it 1 year later, so we'll have a basic idea of what the program is doing by looking at the code. So it's that
Okay.
tells us the simplicity of the language. Then it's machine independent but platform dependent. A C++ executable is not platform independent, right? So it's not platform independent, meaning that when your C++ file is compiled on, for example, a Mac, it's not necessary it will run on your Windows computer. So if I compile a C++ code on my Mac right now, we in when we were using Replit, then what was happening, we were it was compiling the code for us and then giving us the result, right? But it's not necessary that when you have downloaded an IDE and the compiler, so whenever you compile the code, for example, I compile this the code in the Mac OS, it's not necessary it will work on a Windows machine, right? So however, they are machine independent, meaning that one Mac OS code will work on another Mac OS computer. So if I have this Mac, the code will work on another Mac, right? So that means it's machine independent.
Okay.
Alright, so next we have mid-level language. It's a mid-level language, as we can do both system programming that we have already seen. We can build a large-scale application and we can also do low-level programming. Then we have rich library support. We have already seen that feature, that there are many libraries, right? And those are good libraries which will help us a lot while coding. Then we have speed of execution. This is a point. This is an important point. C++ programs excel in execution speed. They are very fast in execution speed, right? So their execution speed is very fast. So since it is a compiled language and also hugely procedural, right? So it's a compiled language and hugely procedural, as it's an extension of C. You can also do procedural programming. It was built for object oriented programming, but you can also do procedural programming in C++. So it's hugely procedural and it's a compiled language. That's why its execution speed is so fast. Newer languages have extra inbuilt default features such as garbage collection, dynamic typing, etc., which slow the execution of the program overall. So, the overall execution of newer languages that automatically do the garbage collection is basically when you pick up memory that is not being used, right? So pick up data from memory that is not being used. So for example, you have a memory where yes, there's some value 10, but no variable is assigned that memory location. So garbage collection, what it will clear up that memory so that other variables can be saved over there, right? So garbage collection is a new thing for us. We are gonna see that in the future in this course. Then features such as garbage collection, dynamic typing, etc. So newer languages automatically do garbage collection and dynamic typing. They have this inbuilt default features that slow the program overall, the execution speed of the program overall. So since there is no additional processing overhead like this in C++, it is blazing fast, right? So it's very fast. Then one point is one advantage is that you have pointers and direct memory access. So it provides pointer support, which aids users to directly manipulate storage address. So you can directly manipulate the memory using pointers and references. So this helps in doing low level programming, right? So this will help us in doing a low level programming. One advantage, a major advantage, is it's object oriented. We know it was an extension of C, and it changed. It's basically not procedural it's not procedural based. You have object oriented based programming in this. And then it's a compiled language. That is an advantage as it contributes to its speed. Now, applications of C++ where or C++ is used in operating systems and system programming. For example, Linux-based OS. They are used in operating systems and systems programming. Like Linux was using C++. Then you have browsers. Chrome and Firefox are made out of C++. You have graphics and game engines like Unreal Engine. So Unreal Engine is an game engine where you can build your 3D games, advanced 3D games. Then you have Photoshop, that was also built, some part of it was built by C++. Then you have database engines like MySQL, MongoDB. These are the two most popular database engines that were also built by C++. And then you have cloud distributed systems that are also built by C++. So here are some key points. So we'll just quickly go through these. It's an object-oriented programming language. We already know that. A strong type system. So C++ has a strong type system, which means that variables have a specific type and that type must be respected in all operations performed on that variable. Now the thing is, in Python, you have already done Python. In Python, we don't have to specify the data type of a variable specifically, right? It directly takes the data type. So if we say x is equal to true, it will directly take that x is a boolean data type. If we say x equals to 1, it will already know that x is a integer data type. But in C++, it's a strong type system, meaning we'll have to type the data type ourselves. We'll have to tell C++ what data type a variable is, a certain variable, so that it is sure that what we are trying to do. So it gives us the advantage. So the basic thing is over here is that it allows us to do as much work as possible. It is allowing us to specify the data type instead of just interpreting the data type itself. It is telling us that we have to specify the data type, right? So it's a strong type system, and that's an advantage, as in Python there can be many a times there can be confusions in data types of variables, right? Then one of the advantages is also low level access. We already know that. Then we have the standard template library. We saw that above. We have cross-platform compatibility. So we'll just read this. C++ can be compiled and run on multiple platforms, including Windows, Mac OS, and Linux. Right. So you can C++ can be used on multiple platforms. You can compile it on Linux and run it. You can compile it on a Mac OS and run it. Right. So it's cross-platform, meaning that you can run it at many popular operating systems. Right. Almost every operating system supports C++. Then performance, it's super fast. We already saw that. Memory management, C++ requires manual memory management. Like many languages like Python only do garbage collection by itself, meaning they clear up the memory locations which are not assigned to a variable. But in C++, unlikely in C++, what we have manual memory management. So we have to do the memory management ourselves. We have to do the garbage collection process ourselves. We'll have to tell C++ that do garbage collection at a certain time. Right. So whenever we require to do whenever we have to do garbage collection, we'll have to tell C++ by itself, and by ourselves, and C++ won't do garbage collection and other memory management processes by itself. And then syntax, C++ has a complex it has a complex syntax, right, that can be difficult to learn at start, for beginners, right? But once you get to know about that syntax, it will be very simple to understand the programs that are there in C++. Then so till now, is the things clear, like the advantages and all?
Yeah, they're clear.
All right. Uh, Great. So next we have the advantages. We already saw them, that there is a large community, platform independence, STL, object-oriented programming language, and performance. Let's see the disadvantages. So there's a steep learning curve. C++ can be challenging to learn at start, especially for beginners, due to its complexity and the number of concepts that need to be understood. So yes, this is one of the disadvantages, that the syntax is a bit difficult, but once you get to know the syntax, it would be very simple in the future. Then you have verbose syntax. It has a verbose syntax, which can make code longer and more difficult to read and maintain. So the codes in C++ are usually longer, right? And the syntax in C++ is a bit difficult to read compared to other languages, and that's why the one of the disadvantage was also steep learning curve. So verbose syntax uh, is basically justifying steep learning curve, that the syntax is difficult and it makes the code longer. So there's a steep learning curve that C++ can be challenging to learn. And then it's error prone. C++ provides low level access to system resources, so you can directly manipulate the memory, so which can lead to subtle errors that are difficult to detect and fix. So there are subtle errors that will cause a big problem in your app. So there will be a subtle error which you won't know you produced, and then it will be difficult to detect and fix, right? So basic features of C++ we have already now seen. Now we're gonna go on programming basics, that what all can we see over here in this course, that what all are there in the basics that we have already seen, right? So we're just gonna go through this very quickly, that what all is there in C++. That there's a basic syntax and first program in C++. So there's a very basic syntax. You have first, learning C++ can be simplified into writing your program in a text editor and saving it with the correct extension .cpp, right? And compiling your program using a compiler or online IDE. The hello world program is the first step towards learning any programming language, like in Python, in C++. Both the hello world program is the first step towards learning any programming language, and is also one of the simplest programs you will learn, right? Next, you have basic input and output, are Cin and Cout, that are there in C++, from that come from the IOStream library, right? And we are gonna Cin and Cout look simple over here when working with them, but they are actually very very complex um, when we are gonna see them in basic input output, we are just gonna see the complexity of inputs and outputs in C++, right? So they are very complex and it's a deep topic to go into, right? And we're gonna learn a lot in basic input and output also, right? And so this basic input and output, then we have comments in C++, that slashes are used for comments. The slash is used for comments, and we already saw comments. Then we have data types and modifiers. Now data types we know, right? But what are modifiers? We saw access modifiers in our classes, but this is data type type modifiers. So what are type modifiers? Type modifiers will tell how much can change how much a data type will consume the memory. Like for example, I'm not able to explain right now, but for example, you can have a short, your integer is usually of 4 bytes, right? So it takes up 4 bytes of memory. But when using short, so if we say short integer, then what we'll say, that the integer should only take 2 bytes, right? So these are modifiers of data types which will modify how much memory space a certain type will take for a variable. So in the next chapter we are just gonna see that only, modifiers and all, so it will be more clear. But the basics of modifiers is that it will tell that how much memory space should be allocated to the variable. Right, so is modifiers a bit like, do you have the overview of modifiers like now?
Yes, but it's clear.
All right. So next we have variables in C++. We already know variables. We have to give the data type first, and then we'll have to define. We have to give the name of the variable. We also know the naming rules of variables and all. Right. So we saw that all in the basic course. Then we have variable scope in C++. So there is scope of variables. You have local variables, global variables, and you have many scopes of variables that we're gonna see in scope of variable in C++ in the variables chapters only, I think. Then we have uninitialized variable in C++. So there are uninitialized variables in C++ also, right? So we're gonna see that also. And we have constants and literals in C++. So all these topics we are gonna see over here. Whatever this is mentioning, we are all these topics we are gonna see constants, literals, etc. Then we are gonna see all the operators also, that we have bitwise operators. We have many types of operators. We have many types of loops. We have while, for, etc. Then we have decision making. We have if, else if, else, all those blocks of conditions. Then we have classes and objects that we saw. We have access modifiers like public, private, protected. uh, then we have storage classes in C++. This will be new for us. Then we have forward declarations in C++. This will be new for us. And then they have errors in C++. So this will be like, we have done exception handling a bit, right? But we're gonna study it in detail in errors in C++. And then we have undefined behavior in C++ that we're gonna see in detail, right? So this was basics, like what this is the overview of what we are going to learn. In deep we are going to learn many new things, right? And then we also saw the advantages and disadvantages of C++. Now we are going to go on data types. So data types, in this we are going to see many new data types. We have the wide character data type that we're gonna see. We have the type def. We have the enum. We have the union data types. So there are some new data types that we are gonna see in this tutorial right now. So now the coding part starts, where we can start. We just had the theory, and uh, is it all clear?
Yeah, it's clear.
All right. So now we are on data type. So all variables use data types during declaration to restrict the type of data to be stored. So we have to specify a data type. We have to give a data type to the variable to tell which data can be stored in the variable, right? So as we know, it's a middle level programming language. So we have to support C++ with memory management. We have to tell C++ that what data type a variable has to be and what type of values it can store. So therefore we can say that data types are used to tell the variables the type of data they can store. Whenever a variable is defined in C++, the compiler allocates some memory for that variable based on the data type. So, for example, an integer is allocated 4 bytes, or double is allocated 8 bytes, right? And so on. So, according to the data type of the variable, that variable is allocated the memory amount of memory, right? So every data type requires a different amount of memory. Integers require a different amount of memory. Double requires a different amount of memory. Your boolean requires a different amount of memory. For example, your boolean can only store true and false, but if it stores 4 bytes, it's no use, right? It only can store 0 or 1. Your boolean can only store 0 or 1, but it consuming 4 bytes of memory does not make sense. So this tells that every data type requires a different amount of memory. So C++ supports a wide variety of data types, and the programmer can select the data type appropriate to the needs of the application. Data types specify the size and types of values to be stored. However, storage representation and machine instructions to manipulate each data type differ from machine to machine, although C++ instructions are identical on all machines. So now it is referring to modifiers of your data types. So when we go down over here, we're gonna see modifiers. Like we have the signed, unsigned, long, and short modifiers that will modify either the values that can be saved in that type of variable, or either the memory location that is allotted to the variable. So if I just say like over here, if I say a long double, or like long integer, so if I give two longs before integer, it will then save 8 bytes, right? So over here they are telling it will save, for a long integer it will save 8 bytes, right? So for a long integer we can say to save 8 bytes. So this modifies how much memory location needs to be stored for a particular variable. Then we have signed, unsigned. When saying unsigned before a variable, like unsigned int, in a signed int, signed is by default for integer. So by default integer is assigned. So integer being signed means that we can have both negative and positive values, right? So an assigned value is your signed integer will tell that we can have from minus to something this till this value. This is the maximum value, this is the minimum value you can go to, right? But when you say unsigned, the values will change. Unsigned means that we want no negative values. So an unsigned integer we can have from 0 till this big number, right? So we're gonna see all these data type modifiers, right, over here in this chapter. So C++ supports the following data types. It has primary or built-in or fundamental data types. That is, it has integer, character, boolean, floating point, double floating point, void, and wide character. Note over here you can see double floating point. Double floating point is basically a double data type, right? So it's nothing new. It's our double data type that we already saw in the basic course. Then we have the derived data types, in which we have the function, the array, the pointer, and the reference. And finally, we have the user defined data types. We can create classes, structures, unions, enums, and type defs. So data types in C++ are mainly divided into three types. There are primitive data types, derived data types, and abstract or user-defined data types. So these data types are built in, so for the primitive data types, these data types are built in or predefined data types and can be used directly by the user to declare variables. For example, int, char, float, bool, etc. They can directly be used to create variables. You can use a bool keyword, float keyword, char keyword, int keyword to create your variable. Note you also have wide character. So wide character looks something like, I'll just show you. So it is w char underscore t. So that is white character. So white character may take its size is 2 or 4 bytes, right? So it's 2 or 4 bytes, right? So it's basically a superset of char, right? So yeah, like your char is 1 byte, your white character will vary from one compiler to to another compiler. In one compiler it may be of 2 bytes, in another compiler it may be of 4 bytes. When using another compiler it may be 2 bytes or 4 bytes, right? So it depends on compiler to compiler, but the white character will basically be able to store more values than the character, so it's a superset of your character. So we're gonna see that in detail also. Then we have two more data types. We have char 16t over here. I'll show you. So over here I'll just right. So over here we have char 16t, that is also a new data type, and we have char 32t, that is also a new data type. So we are gonna see this in this chapter. Then we have derived data types. Derived data types that are derived from the primitive or built-in data types are referred to as derived data types. These can be of four types, namely function that we create, array, pointer, and reference. So we have done function, array, pointer, and reference. We are going to see them in detail in the tutorial. And finally we have abstract or user defined data types. So abstract or user defined data types are defined by the user itself, like defining a class in C++ or a structure. So C++ provides the following user defined data types, like a class, structure, then we have the union, enumeration, and type def defined data type. So now we are gonna see all the primitive data types in detail. So integer, the keyword used for integer data type is int. So to create any integer, we'll use the int keyword. So integers typically require 4 bytes of memory space and range from minus this number to this number. So now, how did we get this number? We know that integers will occupy 4 bytes of memory, right? So it occupies. We know it. We'll just go on Google. So I'll just explain. We integer occupies 4 bytes of memory, right? So that is equivalent to your 32 bits of memory, right? 4 bytes is equal to 32 bits. Yeah, so it's 32. So now every bit can store either 0 or 1, right? So the number range that your integer can save is 2 raised to power 32. So that is 429449679296, right? But but if you see over here, an unsigned int is like this same number, and I'll just take replicate this side, right? So an unsigned integer you can see is 0 to this that we are getting on the calculator, but this is 1 less than what we are getting here, because over here 2 raised to power 32 represents 1 till the maximum number, but in an unsigned integer we also have 0, right? So we'll have to subtract 1 from this maximum number. So we get 0 to 429 this number when an unsigned int is there. But now with signed bit, so half will be negative, half will be positive. So we'll divide this by 2. So in assigned integer, our positive is going from over here we are getting 21474836648. That is the value over here. But this is minus 1. It's 647 over here. It's 648 over here. As this is telling us 1 till this number, the maximum number. But over here in an integer, we in positive numbers we have 0 till 0 till the maximum number. So we'll have to subtract 1 from the maximum number to have a 0 in the range, right? And then half of those will be negative, because negatives directly start from minus 1. We'll have minus and in the end we'll have 648 only, right? So this was the integer primitive data type. Have you understood this much?
Yeah, perfect.
All right. So perfect. We'll continue tomorrow at the same timings then.
Yeah, sure.
Right, so the meeting is about to end as it's 40 minutes. So we'll continue in the next class.